So if you want the Zoom link, it says Happy Zoom Room. It's on the left. Some of us are, hey, let's start. Let's bring it in. Bring it all together. We only got an hour and 15 minutes. Don't make me come over there. Oh, hey, Kool-Aid you. All right, so I pulled up notes, inheritance primer. There was a video up for the templates from last semester. I hope you watched it. On Thursday night, I'm going to do a little project on Zoom at 7:15 to 8:15. I'm going to record it, so if you don't show up, you don't show up. But like we're going to do a little project using the templates and inheritance and stuff like that. But I wanted to go over inheritance a little bit more here. I grabbed the inheritance primer here. I grabbed what we used in the video, which was just, we did rectangle and box. And I grabbed this shit and threw in circle. Oh, I'm down here. I grabbed this and I threw in the circle and the triangle and stuff like that. It is in, maybe I'll copy and post it in an announcement real quick. That way, if you want to pull from directly what I'm using, you can. I put this up. Start of lecture 3. There you go. Oh shit, that looks terrible. Later on, I'll paste. Oh, you know what? Fuck it. I'm gonna repaste it right now. Edit. Someone's drawing on my shit. There's fucking Juan over here just the disrespect. Let's try this again. Let me do control right click paste as plain text. That won't have the fucking 15 lines of someone's got their mic on because it ain't me. I bet that was Juan again. Just over here, just fucking shutting my shit down. All right, there we go. A little bit cleaner. So if you want to grab this from the announcement real quick, we're going to build off that. Give you, 30 seconds to go grab it real quick.
I just wanted to try it out on this. I can have like a separate thing.
I checked out my PS remote play from campus today, and I didn't know because when it first came out, it was like it needs to be on the same Wi-Fi thing. And now, no, I can log in. Dark Souls 3 just popped up on my screen. I'm like, this brings a new meaning to office hours. So just start bringing my fucking controller.
So you play BS or whatever?
I'll play my Dark Souls on during office. I'm not gonna do it in class. We got a lecture in class. Now, if we had a Dark Souls class, that'd be fucking awesome. Although, if that was on the register, the fucking class selection list, I'd be getting some fucking calls about what demonic shit are you guys doing on campus where there's a class called Dark Souls. Because there's some parents and people out there that don't play video games and never heard of it.
For the class image, you should just have someone in like a dark cloak.
Right? I'll be fucking wearing my trench coat every time. All right, so here we are. We've got a global constant in there, a pi, just pre-programmed in. We have class shape, and then we made rectangle and box in the video. And I grabbed circle and triangle here. I like Visual Studios 2022. And I don't know if any of the previous editions have it, but you can like open and close anything that's got brackets. Like the curly braces collapse. I know because down here in the code, I have some text I wanted to have available in case I like need a reminder of how to the actual command. So I hit it, wrapped it up in that in a little couple curly braces. It's pretty neat. I wonder if it showed up in I wonder if it showed up in the announcement like that. Now I'm curious. Nope, it showed it popped open, so you can see what was hidden there, which is good because I'm going to be using it. Let's come back over to our program. So shape was the base, is a base class. Shape is like an idea. We can't really make an object and call it a shape. Whereas I could make a box and I could make a rectangle and I could draw a circle. But if I said I'm going to draw a shape, it's too vague. So like shit that's too vague is often used for base classes or the parent class. Pop that back open. Where did, oh, there. And it's called an abstract, I don't know where my fucking typing went. Oh, it put it down. Let's try this. There we go. There you go. Got to do it on another line so it shows up. It's called an abstract data type, ADT, because you can't use it to create objects. We'll show that later on. We'll try to make a shape, and C++ is gonna kind of go tell me to go fuck myself. But we do have derived classes off of them. So circle, triangle are the new ones. We can take a quick look at what they've got in them. Circle is derived off the public shape. I hope you guys watched the video that was posted on Thursday morning, because like I'm referencing some of the shit we did in there. It's using double radius. It's got the setup, a color first, and then the radius. So we've got our constructor. We've got some accessor methods, the get and set radius. And we've got calculate perimeter, calculate area, and void display info. If we go up and look at shape, shape has calculate perimeter and display info also. So we can do something in parent classes, the base class, if we want to ensure, force everything that uses this base class, inherits it off it, to at least make a method like it, we can enforce this. Like having shapes and having a perimeter, every shape has a perimeter, 2D shape has a perimeter. So we can force every shape class or like rectangle or box or any type of shape that we design, pentagon, hexagon, we can force it to have a calculate perimeter. By putting in virtual lets it, like says they can do it. They can have a class or they can have a function that does the exact method that does the exact same thing or exact same name. The equals 0 portion right here says they must. So the virtual allows it to happen. And if you don't have the equal 0, like the display info doesn't have an equal 0, you don't have to force it on the display info. But every single shape that inherits, everything that class we do that inherits off this needs to have a calculate perimeter by saying equal 0. It's some, I don't know why, what they chose equal 0 for. It's just a way of forcing it. So you'll see that all of our classes that we're going to inherit off of shape have a calculate perimeter. The triangle class has just a single side, not 3 sides. So it's an equilateral triangle, which isn't probably like the, maybe this isn't a very good like triangle one. We could probably edit this later to make it more fun. But accessor methods for the side, it has a calculate perimeter, a display info. The calculate perimeter, it must have this one from the base class having equal 0 on it. And the display info, this is voluntary because it doesn't have equal 0. Notice we don't need to write virtual on these. The base class has virtual. Let me close up circle. Base class has virtual written in front of calculate parameter and display info. It allows the use of the exact same name of the method, which is handy. Why would that be handy?
If you have two of the same type, like two different shapes and then the same double.
If you have the two different shapes and they have the same methods attached to it, if we end up using it in a for loop, we don't have to change the description, because it can just be calculate perimeter every single time. And since we've forced it to happen, it's good to go. These children classes are called derived classes. They're also called concrete classes because they actually make shapes. Now, in this case, we're talking about shapes, but like on Thursday, I'm going to set up at 7:15 to 8:15. It's voluntary whether you show up. You don't have to show up. But if you show up on Zoom, I'm going to set up a one with a person, and we're going to inherit off person. Like, I don't know, maybe do student or employee or some shit like that. We'll throw some templating in to get a little bit of refresher of what, or a little bit of like let's wrap this module up kind of thing. And like, I don't know where I was going with that. The top class is base class. It's not concrete, it's abstract. That's the difference. Abstract versus concrete. Concrete, you can actually make something. So it's a real thing. So triangle has these, and we need to know the constructor methods. The way I did it, I did a little, you'll notice if I shrink them down, each one has a comment of what the constructor is. That way, if I've got the code shrunk down, I can still go up and find out what the constructor method is really quickly. Because like that's really what we're going to use later on to implement these things, right? And if we have the rectangle and the box that we did in the other one, and the codes are all down below. So we've got shape. Then we scope it out. Circle's got it. Let's see. Let's take a look at it. Inheritance. When you're doing inheritance, you have to do, and after you're doing the scope thing and the implementation, you have to do this part right here. So what I'm inheriting from shape is ARG color. And you'll notice we don't need to set ARG color in here, because the way this works is when we run circle later on, we're going to pass in a color and we're going to pass in a radius. So when it comes down here to the implementation, it goes, oh, you want me to pass color over to shape. So it's going to pass color over to shape. And then the only thing that's unique to circle was the radius, which we could see up top. Let's come back up and look at circle real quick. The only variable circle had was radius. So that's the only thing we need to set in the circle one. The other one we pass to the shape constructor. And that is what's going on right here. So we could do it. We could have shape set color, but we don't need it by including this portion right here. And if there's more than one thing to pass, you can pass more than one thing. Calculate perimeter. Oh, good. That's what the pi was in there for. So 2 pi r is the perimeter. They made a calculate area function. And display info looks pretty. It's got a lot more information than we had on our box and our rectangle. Let's play around with some of this in the main and just start designing some of the stuff. Let's see. Let's come up to the main and let's just start out showing that we can't make a shape. Shouldn't work. Oh, nice. It just pops up the constructor right here. Blue. gonna let me do it. Did Visual Studios change? No, it doesn't let me do it. Shape is an abstract data type. It won't let me run it. We'll comment it out and show that that was the only thing fucking it up. There we go. So it doesn't like any attempts to instantiate or deploy a base class because they're abstract. These look all like rectangle. There's more information on the circle. Oh, it says circle properties, triangle properties. Okay. So what else can we do with this? Let's set up an array. Let's see. Can I make it an array? We just saw that we can do the rectangle, the box, the circle, and the triangle. It all ran. They're all inheriting off that shape class. Let's just try to do a shape array. And it's pissed off. It's pissed off for the same reason I couldn't do the thing here. An array is just a chain of objects. And if I can't make a single object, I can't make a chain of objects. But what's neat, so I'm going to say this doesn't work. Single deployment doesn't work, or single instantiation doesn't work. So an array doesn't either. But if I make a pointer, make this a pointer right here, let's say 5. Nope, 3. Keep it short, get the ideas out there. Ah, fuck it, 5. It's not that bad. Say shape 5. Notice there's no underline telling me this is wrong. So this works. Why would shape work or shape pointer work and not shape? Any ideas why it's we'll accept the second one, but it wouldn't accept the shape array? Close. Well, what does a pointer array store? It stores addresses, which is completely valid. It doesn't care what's at the address. So this works because pointers use addresses. And arrays are okay with that. So if I want to do that, let's see, R0 equals, can I just say box and implement the box one? I don't know, what was box? Box took in, oh, let's go back to circle. Circle was easier to show. Circle was just color and then radius. Blue and then 10. And it still doesn't like that. Does anyone know why? What am I missing? Yeah. I don't know if this was in the other video. We need to use the command new. So once the array is declared as addresses of shapes, we have to use new to tell it what's in it. So I can add more to them. Let's just go copy what we have up above. Expedite, oops. Expedite this a little bit. This one takes in the dimensions in a color. Let me grab one for rectangle. R2 equals new rectangle. I got blue. Let's change this to oh, white. Red, white, and blue. That's nice. We'll throw in a circle. Oh, I already got a circle up there. Triangle. And it looks like it takes in a color. Let's go with something crazy like aquamarine. And it's got the side length. I really like what 2022 does. It pops up what the constructor call is. Not all IDEs do this. It's cheat mode. We're technically supposed to do this in like Notepad or some shit like that. You're not supposed to do it with help. The idea is to learn the shit. But like, that slows down learning, I think. We're gonna cheat and add it in there. What side length should we have on the triangle? 5.2? 0.1? Sure, why not? Let's do it. And then I need a colon. And let's see, I've got a rectangle, triangle, circle, box. I think those are all the good shapes I've got up there. Maybe we'll make another box. And these are the side lengths. Let's make it a 3, 4, 5. That sounds like a triangle, but in this case, it's a box. The 3, 4, 5 triangle is the cross diagonal triangle of the corners of the box. Oh, that's dope. I like gray. Gray's got a couple spellings. There's G-R-A-Y and G-R-E-Y. And I think G-R-E-Y looks better. I don't know. That's just me. So I've got this array, and you could have filled it in with different values. You could have all used the same shape, but I want to illustrate what happens. This was an array for addresses of shapes. Not one of these is a shape. It is all shit that is based off the shape, has inherited off the shape. So if we want to do a for loop, plus plus. And all of these had a display info. But the shape thing is now a pointer array. So it's looking at a pointer. It's looking at the address. So if we want to use it, we have to dereference. You use the dereferencing thing, then we can hit it with display info. If you don't like it, that one, there's an alternate form. If I just do array bracket I, and I tell it to do display info, notice it switches it to a pointer. It did it on its own. I typed array bracket I dot display info, and it switched to a pointer. Both of those will work. All right, that was a lot of shit I typed and copied and pasted. Let me give you a little bit to get shit done. So crazy. I was at that conference on Friday with math teachers, and someone I went to graduate school with, like I studied. We were like study buddies because we were, and she graduated just a couple months before me. She was there too. She teaches at Merced City College, and I knew she taught there. Like she got a job there a year after getting out of grad school, but I didn't know she was going to be there. I'm like, holy shit. All right, let's take a gander at running it. Now I left both of them in, so it should be. So this looks terrible. So I forgot to put spacing in first off. So let me just clean this up and let's do out. Let me do out a C out end line up here. Put some shit like that in. And then I will throw this in to each for loop at the end. Spacing is your friend. A pretty program is all about the way it should do it. And I still don't have it pretty enough because I don't have a space between these. There you go. All right, let's take a look at the prettiness. So I'm going to scroll up. These were the 4 at the top. I'll disable them next run around. Both circle calls. The first one we had was a circle. I called both circles that way. Then next run through was the box, and it called both boxes. Then rectangle, then triangle, then box again. And each time it's producing the same thing. So one of these is extra. I don't know which one you like. I'll comment out the top one. No, it's coming out the bottom one. Because it's easier to remember this. So if you get more practice with this, that becomes easier. This for loop right here indicates an idea, shows off the idea of polymorphism through inheritance. And it's on the line. It accesses display info from 4 different classes, all with the same command. And that's because we set it up with a base class that had virtual void display info. And then all of our children class, our dependent classes, inherited off of it. And since we made the array based on shapes, it went to the shape thing and said, all right, we're going to use the commands that are in shape. It's kind of neat, right? It's pretty handy, right? Like, what is going on here? Like, oh, here we go. I gotta tell it here. Let me, okay, so let's make that brush thicker. Width over here. Let's do that. So we had an array here, and these are all addresses. Stop! What are you doing? So what did I have? I had a circle. Oh, these are all addies. Wow, that's fucking hard to write. Using a mouse to write sucks. So these are all addresses. But this was a circle. This was a box. Right. And we had a rectangle. We had a triangle. And I think we had another box. Yeah. But all that was stored here was address. And then what we just went in and did is we grabbed display info on each of them. And since this was a shape array, it knew, it said, okay, we've all got display info on all of them. We didn't need to change the command. We can use the same command and it's good to go. Pretty handy. This was my idea to use this rather than trying to do the fucking projector. It's not a tablet with a pen, so we're stuck with a mouse. But I think if I really need to do text, I can. There's a way of doing text right there. All right, let's come back over here to our code. And arrays are a little bit limited. We have to set them up ahead of time. Like if we were doing a database with people, like the project I'm gonna maybe we'll work on Thursday night, you will want to be able to add to it at any time. So arrays are limited. Let's up our game and go to vectors, which we can populate at runtime. You guys ready? No yawning. Juan, do you see Ainsley around anywhere? Ever? Not in here, but I mean on it.
Last class.
She's in your classes?
Oh, no. But last class she was here.
What? Last semester she was.
No. Or I did see her. I don't remember which class.
If you see her, tell her how much you like being an SI.
Okay.
Trying to recruit her to be my SI for calculus next semester. All right, let's go give it to him. We're gonna do a vector. That's not how we do it. Vector. And I don't want to do a vector of shapes. I'm going to do a vector of shape pointers. Let's just call it my shapes. There you go. Oh, you're doing it. Are you enrolled there? Or are you SI for that too?
No, I'm enrolled in it.
Well, you're busy.
Yeah.
I don't know that Tracy would let you do fucking 3 different. All right, so we got a vector shapes, shape addresses. We're calling it my shapes. How do I add to vectors? What's the command? Hitting dot just showed it to me right away. It's right at the top, push back. So we're gonna do push back, and we still need to do the new shit. So what I'm gonna do, let's hide that for loop so I can get more information on the screen. I'm just gonna come up here and copy these and put those in the pushbacks. I mean, I could type them out and come up with new ones, but What's the fun in wasting your time? My name isn't Redden.
Hey,
Yeah.
I would not hear anything against.
Let me rephrase that. My name isn't John Redden. Tracy doesn't deserve that. You want to know bad? It's program review time for computer science. He's been teaching this class for 20 fucking years. The one semester we got to do it every 5 years. Where is he? He took a fucking sabbatical this semester. So I get to do program review for something I just started teaching a fucking year and a half ago. And I've never done program review before, so I don't even know what it entails. Little bastard took the fucking time off. All right, my shapes. What was I doing? I was doing pushback. Let's go grab the rectangle. I'm tired of fucking copying and pasting. Turquoise. No. Maroon. 3 point. Oh, let's triangle is using pi. Let's go with pi. That's good. We'll just do 4. We could do more if we wanted, but we'll do 4. Now, what do we got to do? Let you give you guys time to implement your vectors. I'm going to comment out that for loop. Oh, it said, no, you can't comment it out like that. You got to comment it all out. All right. Everyone got their vector? I don't hear clackety clack, so it sounds like people are done. How do we put this out? Like we got 4 here. But maybe we should just do my shapes dot size, right? That's the better way because the vector size changes. And you don't want to exactly, you don't want to change it every single time. Now, what do we got here? If I try to do my shapes I dot, oh, it jumped to the pointer. Excellent. Will that work? It should because it's doing the pointer. This should be similar to dereferencing it. Oh, look at my chump ass didn't put no spaces in. Ah, terrible. Let's come up here and comment this shit out too. Throw some spaces in it, you scrub. I kind of like having the asterisks denoting a little barrier there. I kind of like that. I think it made it look prettier. Why is it? I think it's just being moody for no reason.
be able to push back everything. Not just do it.
Looks all nice and pretty. Come test time, prettiness counts. If your program looks like shit, it's gonna get marked down. Like this display. Not a lot. It's not a big markdown, but it does count. So make the output pretty on test time. Creativity, like if you've got an opportunity to, some of them are just like have strings here or something. If you're creative and have some cool story or do some fun shit, that's usually extra credit. Last semester, the final had set up these game buttons on a controller. Set up 4 game buttons on a controller. And some people were really fucking creative. Like one of them, I think I just said do like punch 1, punch 2, or kick 1. I don't know. Whatever I fucking said. But some people, they did more. They added more controller buttons and they were more specific. The trigger did, shot. There was jump. There was that was fun. I like fun stuff. If I'm entertained while grading, that's only a good thing. All right. So another way of doing this, because we like doing this shit, displaying it, is my shapes.at. Display. And I actually like this one better. Oh, it says you, well, look at this. It thinks I'm making this a local variable. It didn't think I or 1 or better was a local variable. But this is definitely a command. We're going to go over this later on. All right. So maybe I'll throw out a end line in between it, just to show that they do the same thing. So yet another display of polymorphism. And we'll hit on this polymorphism thing more than once in this class as we start doing more stuff with it. But it's super handy to have like one command to rule them all. If you got a whole bunch of things that are all related, like shapes in this case, any command that they all will share in common, and you need to make sure they all share it in common. Having one command to do it makes display or doing stuff with it a lot easier. Now, you'll like this. Let me do it before that thing there. I'm going to comment out that one. And I'm going to put it here. See out. It's called type ID. And you actually need the C out because this just returns a thing. We're going to dereference my shapes at I. And once that's dereferenced, we're going to say name. So let me put a little space on the screen so that's a little easier to read. Type ID, the dereference to what's stored there, and then the name. Now, cout's just to display it to the screen. You can use type ID in other ways, as we'll talk about in a second, but what does it do? It tells us what each class is. So it tells us what it is. So, like, if you've got a bunch of fucking things that are inheriting off the same base class, and like you need to know, like you want to have different shit go on for different things, we could set up something like in here, like, let me do it down here. If type ID, let's see if this works. Let me copy that shit. I haven't tried this before. I got too many parentheses. See how, no, it just wants triangle. I don't even want that. It's a string. Maybe it wants the string. Yeah. Spell it right, Jones. And I will comment out that line right there. And we're just using it right here. We'll see if this works. I didn't try this last semester, but hey, the fucking greatest thing about computer science, just dabble, fucking play around with shit, see what works. The IDE is pretty helpful when it tells you shit isn't gonna work, so you're not wasting your time. And let's face it, no one knows everything about C+ or any of these programming languages. Not even the people that fucking came up with them, because people add new shit to them all the time. It didn't do it, you son of a bitch. So let's eliminate class. Let's try that. What? I guess that didn't work. Let's look up, see how to make it work. C++ type ID. Load. If the expression identifies an object of polymorphic type, that is a class that declares or inherits at least one virtual function, the type ID expression evaluates the expression and then refers to the object that represents the dynamic type that we did at runtime. Show what's printout. Did they do anything with it other than, look at this look at this garbage. Who thought this was useful code to put up here? All right, let's go to cplus.com. Yeah, this feels like a redden site. Is it www? There we go. Okay. Type info, let's see. Annoying. I don't want to read all your shit. That wasn't helpful. Print F. Jesus, this is just old. I'll look at that up more later on. We'll see if we can get that shit to work. That would be nice. It's not working yet. Something to look up when we got more time. But if you can always use it as that one right there and get the shape out of it. I wonder if we could say type info. Nope. All right, we'll look at that more later. Doesn't do anything now, so at least it still runs. Something else is going on here though. We're doing vectors, we're doing it dynamically at runtime, which means we're sucking up memory. When we're done using it, we should clean up our hard drive. So we need to do some memory management here. And we want to do two things in our memory management. We want to delete the shape that's stored. And we want to shorten the vector. So we probably want to start at the end. End of the vector, and that uses back. Back gets us to the end of the vector. I'll do that. I'll make that a better sentence. Okay, then we're gonna go draw out what we're doing and reason out what's happening here. What order should we do it in? Delete, and then short. How do we shorten? How do you shorten a vector? How do you remove something from the end? It's pop, right? So we got delete and pop back. Those will be the things we're looking at. So let's come over to paint, and we only had, we'll pretend that's right. Where's my eraser? Wow. Right. So let's discuss. Wow, it already went back to the shitty smallest size. Let's look at doing delete first. and then pop. And then we'll look at pop versus pop, then delete. So if I do delete first, let me draw the box again. I'm not going to draw each shape, but so we do delete first. It takes what's in here and it gets rid of it. That's the delete step. And then the pop step takes that thing and cuts it off. Which looks like that's the way to go. Will it work in the other order? Let's draw and see what this would look like. If I do pop first, pop takes this whole thing and cuts it off the vector. Let me do this. And get rid of this picture real quick. Right, that part right there real quick. I want to get more than that. So it comes along and it took this off the vector, but the data is still assigned. Assigned in this square. I need to finish it. I can't just leave it as ass. Data is still assigned. So whatever was in that the end of the vector is just going to be free floating. The shape's there. It's stored there. It's being used by the program, but nothing we can do about it. So this looks like and then, so the first thing that it would delete this one first, which is the new end, because it's already taken the first one off. So we've got some free floating thing here. And it looks like when we get to the beginning, if we pop off the beginning, there's nothing left there. How do we delete? I think we would end up with an issue at the beginning of the vector. So this one isn't good. And you might think, who gives a fuck? The program's done when we're over with this afterwards, right? I'm just doing this to test stuff. But like, let's say you're playing, I was playing Dark Souls 3, so let's say Dark Souls 3. And you've got monsters in there, and you've got like how many monsters are in the area. And as monsters are killed, you just knock their shit off and leave the data of their dead body there, which I guess it kind of does. The body lays there. So maybe this isn't the best. Let's say the body decays and evaporates in Dark Souls 3. It doesn't, but let's say it does. You don't want the body there. And if we did the pop delete, we're saving all the memory of the dead bodies. And if you play Dark Souls 3 a lot and you just die a lot, like, it's not wiping out the memory ever, because you're still playing it. You die, you run back out, the monsters are reborn, and you do it again. And so your computer is filling up with dead bodies, Dark Souls dead bodies. The memory is being wasted. So the idea is, like, it seems like pointless on something like this, but think big picture. When you're done using shit, get rid of it if it's occupying memory. Because in big programs, you don't want shit clogging up your RAM. I know we have access to a lot of RAM these days.
That's why in like older games like Mega Man, like you can go somewhere and then enemies will just happen to respawn.
I have no idea. Might be. So that's the idea of doing that. So we're gonna go with the delete and then the pop. But it's always good to reason out what you're doing. So we're gonna go 4 in. Let's do J this time just for fun. J equals I want to start at the end of the vector. So what was my vector called? My vector was called my shapes. And I want to go to size. But that's going to tell me the entire size. So like my size is 4. But like when it's referencing an element number, we start at 0. So really that last one is 3. I probably want to do -1. We'll find out. We'll leave it without the -1 and see what happens. And then we'll go j greater than 0 is now the criteria, and j minus minus. So here we're decrementing. We're so used to using plus and going up, but we can go the other way. And since we're popping off the end, it's kind of handy. All right, so we need to delete the shape first. So we got my shapes at J. Oh, no, not J, not J. Let's just do back. It's at the end. My shape's back. That's what we want to delete. So delete is a command and it goes in front. And maybe I'll come up here. And so I'm going to copy this C out thing. And I'm going to put in some information here so that like as we're running it, we can see what's happening. Deleting the shape, deleting the, delete that. This will give us a little information while we're doing it. And then we want, that was delete, and now we want to do pop back to shorten the vector. Don't need it storing dead bodies in the vector anymore. Kill the vector. My shapes dot pop back. Bam. Nope, don't even need J. I think that'll do it. I'm going to be switching throughout the semester to that paint window a lot. Yeah.
We use J for a lot, but like
Yes. So used to using I just typed it. Good catch. It would have told me that I was wrong. I would have been, what? Fuck you. And then everybody that saw that would have said, yeah, we knew you were a scrub. All right, let's see what happens. Whoa, it told me to fuck off. So let's go back and like, let's hit stop. And I don't need that information. Let's come back here to the source. I'm gonna do -1 here because I think it's trying to do too many. There we go. Now it said deleting class triangle, deleting class rectangle, deleting class box. The top one was circle though. It didn't get rid of circle. So my memory management is not good. Maybe I need to do greater than or equal to 0. Yeah, I was trying to, I don't know why that. Yeah, my shapes at J was fucking up. Because it was saying my shapes at 4 when really my shapes 3 was the only one it had. Now this should delete them all. And notice it's still doing them in reverse. We had circle, box, rectangle, triangle, and deleted them in the reverse order. Any questions? So if you're making video games and shit like this, you could, let's use any game where you kill shit as an example. Dark Souls, you have monsters, you have boss monsters. We could make a base class with monsters in it, and like maybe that'll be our project. Let's think about a project for Thursday night. Adventure role-playing games. Have you kill monsters. So let's make a base class of monster. What should every monster at least have that we could inherit for all of our sub monsters? They have health, right? So base characteristics or data types, not necessarily data types, but variables. They have health, maybe some sort of armor rating. They have a loot table. We haven't gone into tables yet. This is gonna be fun when we get the linked list there one. If I can make a loot table. What else they have? Oh yeah, what do? They don't just sit there and let you beat on them. So maybe an attack type and damage type, and damage. Like, do they just hit you with a physical weapon, or do they breathe fire on you? Because if you like Dark Souls, you got different resistances, frost and poison and fucking fire. So it matters what the damage type is. But all this red, it doesn't like any of my C outs, even though every single one works. And then, so which of these should be forced to the rest, the descendants or children classes? Kind of all of them, right? Nothing special there that's unique. All right, so I don't know, monsters in Dark Souls or like Walking Dead games, Resident Evil. You've got like zombie. So we could do zombie traits. They usually have trash loot. Then we have like a bunch of like weak guys, and then we have a boss guy. So maybe between base class and monster, we could have another base class off of monster that says trash mob or boss mob. I don't know. Is that even necessary? No, but it helps practice inheritance. So fuck it. We're going to do it. So we'll do some zombies. I don't know, some evil humans. Maybe some knights in there. There's always some fucking wizard. Sorcerer. Yeah, this is an hour-long project. The idea is to just walk through simulating some of this. What? Still didn't hear it. Oh yeah, we're gonna do it from scratch. I'm literally making this shit up right now. What we're gonna do? I haven't done this shit. 7:15 on Zoom. God damn! How old are you? Fuck! I don't even go to bed at 7:15. I actually stay up kind of late. I get stuck reading. Yeah. You don't have to show up to it. It's completely optional. I'm gonna record it and post it on Canvas. No, I don't have the class space. It's not in person. Thursday nights, we don't have class in person, so it's just gonna be on Zoom. 7:15 to 8:15, or probably 7:15 till we're done. Is a better way of doing it. If we go to 8:30 or if we go to 7:45, you know, the idea is to explore some of this shit. Other than that, let's wrap it up. You can GTFO, or you can stick around. As a reminder, Juan's doing the SI thing after this, right? It's on Mondays and Wednesdays. So if you want to discuss some of this shit without Hefe in the room, go, why is he going so fucking fast? If you wanted to have Juan tell me shit like you guys don't want to tell me, Juan will happily step up for you. Other than that, I'll see you guys on Wednesday. Right? I hope this was interesting.